Guys, welcome back to our channel Get Play Soon. In this video, we are going to discuss about multi-level queue scheduling algorithms. In the previous videos, we have discussed so many scheduling algorithms like first come first serve, scheduling job first, priority scheduling, etc. This is the 28th video in the series of operating system. So if you haven't watched my previous video set, make sure you watch them. So without any further delay, let's understand multi-level queue scheduling algorithm. This is a scheduling algorithm used to manage and prioritize the processes. Now let's see how this multi-level queue scheduling algorithm works. So in this algorithm, the main idea is to group the process into different categories. So we group the process into different set of categories based on the characters or the priority levels of the process. So when I mean the characteristics, for example, it considers CPU time, input-output access time, memory time, all these things comes under characteristics. So based on the process that arrive in the ready queue, we can divide them and put into separate baskets, put into different categories. And by dividing them into categories, we can easily schedule them. So this is the concept behind multi-level queue scheduling. Now let's see in detail how it works. So you have understood the approach, the main idea of multi-level queue scheduling. Because of this, the processes are executed efficiently based on the urgency or importance. So if all the important tasks are executed first, so the system performance also will be optimized. This ensures important tasks get immediate attention while less urgent tasks wait for their turn. When I say categories, the processes which enter into the ready queue are divided into separate categories. Now let's see a couple of categories. For example, we have system process. System process are important process which are executed by the operating system itself. We can have one more category like interactive process. As the name itself suggests, the interactive process involved with user interaction. It needs to be responsive. It needs user input. So we have another type of category like batch process. Batch process are those type of process which can be executed in the background. It does not need any user intervention. And we can have one more category, that is student process, which has the lowest priority. So for example, I am giving these 4 types of categories. There can be more type of categories as well. So whenever the process enters, this multi-level queue scheduling algorithm will divide the process into different categories. So for example, there are 3 processes entering, P1, P2 and P3. So P1 may enter into interactive, P2 may enter into system, P3 may enter into batch. So depending upon the characteristic, it is the category is assigned. In general, in other priority scheduling algorithm, we have only one queue. But when it comes to multi-level queue scheduling, each category has their specific queue. For example, in the problem you are solving, there are 4 categories. So there will be 4 queues like Q1, Q2 and Q3 and Q4. Now the question arises, what if all the queues consist of process? So if all the 4 queues have process, then the question arises, which process to run first on the CPU when all process queue have some processes. So which to run? So to understand which process to run first, we have 2 methods. The first method is fixed priority preemptive scheduling method and the second method is time slicing method. Now let's look at the first method. Fixed priority preemptive scheduling method, as the name itself suggests, it is preemptive. Preemptive means, I am recalling you again, preemptive means the capacity of interrupting the running process is known as preemptive. If it is non-preemptive, you cannot interrupt the running process. So in the fixed priority preemptive scheduling method, each queue is assigned an absolute priority over the other queues. So you can see there are 4 categories as we discussed earlier. Now the categories are in the form of a line. It is in the form of a range. So from student process to system process, it is in the range of lowest priority to highest priority. Therefore, the order in which the process run are system process queue is greater than interactive process queue, greater than batch process queue, greater than student process queue. First, initially, all the processes in the system process queue are executed until this queue is empty. Then we move to interactive process queue. When interactive process queue is empty, then we move to batch process queue. Similarly, when this is empty, we will move to student process queue. But if a higher priority process arrives when a lower priority process is running, For example, if you are running in the student process queue and suddenly there is one process enter in the batch process, then because this is a preemptive method, the process which is running in the student process queue is interrupted. We will continue and we'll complete the batch process, and then again we'll come to the student process and complete it. So this is how the process runs. So this is the concept of fixed priority preemptive scheduling method. So I hope you understood this. Now moving ahead, we have time slicing method. Time slicing method means each queue is allocated a specific portion of CPU time by default. So, and the process from each queue are executed before moving to the next queue. For example, here in the example we have discussed earlier, we have 4 queues. So, this is having the highest priority and this is having the lowest priority. Therefore, by default we will assign this time slicing, that is 50% of the CPU time is assigned for system process because they are more important and because OS have to do it. And coming down, this will take 30% of CPU time. This will take 15% of CPU time. This will take 5%. So, time slicing method is nothing but assigning CPU time by the number of categories present. Right? After execution of process from each queue, according to their allocated CPU time, the scheduler again returns to the first queue, that is system process, to continue. Okay? This is how time slicing method works. Now that we understood how the processes are run, now let's see how the processes are executed. I mean, in which method, in which algorithm. So, each queue can implement different scheduling algorithm depending on the use case. So, depending on the category, depending on the type, it can decide which scheduling algorithm is beneficial. So, now that we discussed how the CPU time is allocated, how much time, which process to run first. Now, let's see how the queues are executed. I mean, in which algorithm, which method the queues are executed. To understand that, so all the process inside this queue can implement different scheduling algorithm depending on the use case. So, the Q1 will have some kind of scheduling algorithm, Q2 will have other type of scheduling algorithm, Q3 can have different. So, for example, let's say system process might use FCFS, first come first serve. Interactive process must use shortest job first. Batch process can use some other things. Student process can use some other thing. So, it totally depends on the use case, right? So, this is how multi-level queue scheduling works. So, I hope you understood this video. I hope you understood this algorithm. In the next video, we'll discuss an example on this algorithm. So, that's it from my side. Thank you so much for watching this video. Please like, share and subscribe to our channel. Get placed soon.